Module 5.1, Quadratic Functions and Variation. This is chapters 3.1 and 3.6 in your book. 5.1 opener. As stated before, the quadratic equations and therefore quadratic functions are used to model motion. In this section, we're going to look at quadratic functions in more detail, and then we're going to look at a specific type of problem called variation. Some important concepts to focus on. A quadratic equation can always be solved using the quadratic formula. Okay, sometimes you don't have to factor, you don't have to complete the square. You can always solve a quadratic equation using the quadratic formula. You're also going to need to memorize the two types of variation problems, direct variation and inverse variation. Quadratic functions. Definition. A polynomial function is written in the form some coefficient a sub n times x to some power n plus another coefficient a sub n minus 1 times x to the n minus 1, etc. Up until you maybe have just a coefficient by itself. Okay. A specific type of polynomial is a quadratic function, a quadratic polynomial, in which you just have a times x squared plus b some number times x plus c. Okay. And we've looked at that before. Remember that's usually represented graphically by a parabola. If it's a degree 2 polynomial, then it looks like a parabola. If this coefficient a is positive, then the parabola opens upwards. If a is negative, if a is less than 0, then the parabola might open downwards. It might look like this. Well, it will open downwards. Okay. A quadratic function also has a vertex, right, that's given to you by negative b divided by 2 times a. In other words, this point right here, the lowest point or the highest point, is given by negative b divided by 2 times a, where your b is the number in front of x and your a is the number in front of x squared, comma, the function at negative b divided by 2 times a. So it's a point. It's an x value and a y value. The x value is negative b divided by 2 times a, and the y value is what you get when you plug that number into the function. So let's look at an example here. Let's look at 3x squared plus 2x minus 4. Let's say that's our function. Right, we know it's a parabola and this 3 is positive, so we know it has to open upwards. Maybe it looks something like this, we don't know. But because 3 is positive, we know at least it opens upwards. And we're going to try to find the vertex. The vertex is given again by negative b, negative 2 divided by 2 times a. That's your b, that's your a. So 2 times 3. And then it's the function at negative 2 divided by 2 times 3. Negative 2 divided by 2 is negative 1, so this is just negative 1 over 3. And this is the same thing, the function at negative 1/3. So we're going to have to take this negative 1/3 and plug it into x and x squared. So that's going to be 3 negative 1/3 squared is 1/9 plus 2 times negative 1/3 minus 4. This is 1/3 plus, or sorry, minus 2/3 minus 4. And we're going to use the calculator here to simplify this really quickly. Alright, so we have 1/3, and I'm going to put everything in parentheses just to be safe. 1/3 minus 2/3 minus 4. and hit enter. And it's a fraction, so I'm going to have to go to math here. It's a decimal, so I'm going to have to go to math and fraction and turn that into a fraction. So negative 13 over 3 is what that equals. So this is equal to negative 1/3, and the function at negative 1/3 is negative 13 over 3. And that's where your vertex is going to be. So this is negative 1/3, negative 13 over 3. That looks about right. Vertex form of a quadratic function. Another way of writing a quadratic function instead of ax squared plus bx plus c is equal to a, some other number a, times x minus h squared plus k. And again, this tells you, we've already mentioned this, but this tells you what the vertex is. The vertex in this case would be h and k. Right. Notice it says x minus h and then squared plus k. But the vertex is still just h, whatever's being subtracted, and just k, whatever's being added. And similar to before, if this a is positive, then the parabola opens upwards. If a is negative, then it opens downward. Okay, so here's a function, and we're going to try to find the vertex form, and we're going to try to do this by completing the square. So we want to write it as a times something minus something squared plus k. So we know what the vertex is. So we can say the vertex is h comma k. So we're going to complete the square here. Remember, to complete the square, we need this number right here to be 1. So we're going to divide everything by negative 3. We're going to factor out the negative 3, actually. We're going to say negative 3 x squared minus 2/3, or plus 2/3 actually, minus 1/3. And check to make sure that you factored it correctly. If you were to multiply in the negative 3 back inside to everything, you would get negative 3x squared minus 2x plus 1. Okay. And we're going to complete the square. Remember, how do we do that? Now we just need to write, now we just use the, oh, I forgot my x here. Now we just use the first two terms there to write x plus, not 2/3, but half of that, 2/6. I'm going to put a giant parentheses there. X plus 2/6 squared minus 1/3. And remember, if we had an equation, if we had this e equal to 0 or something, then we would add plus 2/6 squared on the other side of the equation. But we don't have an equation, so we can't add that. So we have to subtract 2/6 squared to the same side. And then we simplify. Negative 3 x plus 2/6 squared, or 2/6 is the same thing as 1/3. And then what does this equal here? We can use the calculator to simplify that. Right. If you use the calculator to simplify that, you get plus 4/3. Or sorry, minus 4/9. Minus 4/9. And then we're going to multiply in the negative 3 to that term and then to the last term. Multiplying in a negative 3 would give us negative 3x plus 1/3 squared plus 4/3. And there's your vertex. Your vertex now is x minus a negative 1/3, so negative 1/3, 4/3. This negative 3 tells you it opens down. The parabola opens downward, and the highest point is at negative 1/3, positive 4/3. For the following function, I want you to try to find the x-intercept, the y-intercept, and the vertex. Then sketch a quick graph of the function. Already you know how to do a quick graph, right? This is -3, so it should look like parabola downwards somewhere. And maybe it has some x-intercepts and some y-intercepts maybe. So that's what we're going to try to find. For the x-intercepts, remember the first thing you should say is y is equal to 0. In other words, 0 is equal to -3x squared minus 2x plus 1. And we could solve for this using the quadratic formula. The quadratic formula says the solutions are x is equal to -b, or 2, plus or minus the square root of b squared, or 4, minus 4 times a times -3 times c, which is 1, all over 2 times a, all over 2 times -3, or -6. Remember, what are we using here? We're using -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Okay, and then we're going to simplify. 2 plus or minus 4 minus 4 times -3. That's -4 times -3 is positive 12. So this says 4 plus 12, or the square root of 16. But over -6. But the square root of 16 is 4, so this says 2 plus 4 over -6, and 2 minus 4 over -6. 2 plus 4 is 6, over -6 is -1. 2 minus 4 is -2, over -6 is positive 1/3. So those are your x-intercepts. At -1, let's say that's 1, 1, 2, 2. At -1, 0, there's an x-intercept. And at 1/3, so not all the way over there, but somewhere like right there, there's another x-intercept. The y-intercept is when x is equal to 0. So y-intercept is when x is equal to 0. If x is equal to 0, we have -3, 0 squared minus 2 times 0 plus 1. All of this cancels out except for the 1. So your y-intercept is 0, 1. Let's say that's 1 up there. There's your y-intercept. And how are you going to find the vertex? Right? You can write this in vertex form, or you can just use the formula. The vertex is equal to -b divided by 2 times a. And then the function at -b divided by 2 times a. -b is -2, or positive 2. 2 times a is 2 times -3, or -6. And then this is the function at 2 over -6. This is the same thing as 1/3, -1/3. And then once you plug in -1/3 in here, -1/3, -1/3, and remember, put that in parentheses, square it. And add 1, then you should get your number. Notice though that this function, -3 minus 2x plus 1, is the same one we did before. So we know the vertex is -1/3, 4/3, because we already did this problem using complete and square. So we know this is going to have to come out to be 4/3 when we plug that in there. So -1/3 would be over here somewhere. And 4/3 is a little bit over 1, because 3 goes into 4, 1 and 1/3 times. So there's your highest point, the vertex. And your parabola points downward. It looks like that. Working direct variation and inverse variation problems. When two variables are related to each other by a constant multiple, we say they vary directly, or they're proportional. For example, the number of miles your car can drive varies directly to the number of gallons of gasoline your car has. Right? If you can go 22 miles to the gallon, it's not very good. But if you can go 22 miles to the gallon, then we say the miles varies directly to the number of gallons you have. If you have 2 gallons, how many miles can you drive? Then you can drive 44 miles, right? You multiply it by 2. So if we say that y varies directly as x, in other words, y is directly proportional to x, then we can write the equation as y is equal to k times x. In our example up there, the miles, y, is equal to 22 times the number of gallons, x. And we call that number k the constant of variation. In other words, k in this example would have been 22. Likewise, we say that y varies inversely as x, or is inversely proportional, if the equation we're working with is y is equal to k over x. Here's an example. If x varies directly as y, and x is equal to 2 when y is equal to 5, find x when y is equal to 10. Notice that the order matters here, and this problem seems complicated, but we're going to take it step by step. X varies directly as y. It means you start off with x, and you know it equals to some number k times y. And then they give you more information. X is equal to 2 when y is equal to 5. So that tells you that k has to equal 2/5. And now we have our general formula. X varies directly as y. X is equal to k, which we know is 2/5, times y. Now it says find x when y is equal to 10. In other words, plug in 10 for y. 10 divided by 5 is 2. 2 times 2 is 4. If z varies inversely as w, in other words, z is equal to k over w, and z is equal to 12 when w is equal to 4. In other words, 4 times 12 is 48. Find z when w is equal to 6. We're going to write down our equation again. We know that z varies inversely as w, so we know z is equal to k, which is 48, over w. So find z when w is equal to 6. 6 goes into 48 8 times. And we're done. Try the following on your own. Find the vertex, x-intercept, and y-intercept of x squared plus 2x plus 1. Remember, for the vertex here, we need negative b divided by 2 times a, and then the function at negative b divided by 2 times a. A is 1, b is 2, c is 1. So it's negative 2 over 2 times 1, or negative 2 over 2 is negative 1. And then it's the function at 1. The function at 1 is 1 squared plus 2 times 1 plus 1, or 1 plus 2 plus 1, which is 4. That's our vertex. X-intercept is when y is equal to 0. So we have to solve the equation 0 is equal to x squared plus 2x plus 1. Remember, the quadratic formula solves that. You can also factor this. This is equal to x plus 1 times x plus 1, which tells you, remember, that your two solutions are x is equal to negative 1 and x is equal to negative 1. The y-intercept So our point here would be negative 1, 0. The y-intercept is when x is equal to 0. When x is equal to 0, we have 0 squared plus 2 times 0 plus 1. So when x is equal to 0, our y value comes out to be 1. And we're done. Negative 1, 0 for our x-intercept, 0, 1 for our y-intercept, and negative 1, 4. Oh, hold on. Oh, this is supposed to be negative 1 here. Negative 1, which would have given you 1 plus negative 2 plus 1 would have been 0. So this should not have been 4, it should have been 0. So our vertex should be the same as our x-intercept here. And then it goes back up. Our vertex was negative 1, 0, and our x-intercept was negative 1, 0. Okay. Be careful. At first I plugged in 1 instead of negative 1. So you got to make sure we plug in the correct number. Okay, you should now be ready to start on homework 5.1.